All right, hyperbolas, completing the square, and then graphing. So the first thing I'm going to do is I'm going to put my x's together, put my y's together. That 108's getting moved to the other side. Here we go. So 16x squared plus 96x minus 4y squared minus 40y, and that's going to equal a negative 108. Okay. So I'm going to factor out a 16 from the x's. I'm going to factor out a negative 4 from the y's. And y'all, when we factor out a negative, the signs change. So be mindful. So taking that 16 out, that's going to be x squared. Y'all, 96 divided by 16 is just 6. So plus 6x. Now I'm ready for a blank. I'm going to factor out that negative 4. That y squared term is now positive. Negative 40y. Divided by negative 4 is positive 10. So plus 10y, ready for a blank. All right, and then on the other side, guys, I don't have a lot of room. So this negative 108, I'm going to move kind of floating at the top. And I'll just put my values there underneath it. Okay, now it's time to wrap these in nice little squared packages. All right, here we go. So half of 6, of course, is 3. 3 squared is 9. Half of 10 is 5. And 5 squared is 25. And again, guys, I am going to use my highlighter and highlight these because I know I'm not just adding a 9 and a 25 because there's values here that are being multiplied by those outside numbers. 16 times 9, that's 144. So I know I've added that value. And then 25 times a negative 4 is a negative 100. So y'all, when I add up all these numbers over here on the right side of the equal sign, that is a negative 64. Now remember, hyperbolas are related to ellipses. They have to equal 1. So I'm going to divide everything by negative 64. So the signs are going to change again. So divide everything by negative 64. And just a reminder, it's nice that there's a self-check here. You are so on the right track if the numerators wipe out to 1s. So that's a nice self-check that you can always check about. Positive 16 divided by negative 64. This is a negative 1/4 right here. So this fraction turns negative. So negative x plus 3 squared over 4. And then, y'all, negative 4 divided by negative 64, this is going to turn into a positive fraction. 4 over 64 is 1/16, but it's positive now. So it's going to be plus y plus 5 squared on top over 16. And of course, anything divided by itself is always a positive 1. And guys, this is why the top changes on hyperbolas. We always list the positive fraction first. So boom, y is about to go in the front. If y is in the front, we know it's going to be a vertical hyperbola. So y plus 5 squared over 16 minus x plus 3 squared over 4 equals 1. Okay, let's go ahead and graph this. So we know for sure that it's vertical because our y term was positive. A value, just square root of the first denominator. B value, the square root of the second denominator. C value, you just add those up, then square root it. So A is 4, B is 2. C is going to be the square root of 20, and I'm writing the square root of 20 out here because it is easier for me to visually see this is in between 4 and 5 spaces, but there's a perfect square in 20, so we have to simplify this. So the C value is 2 square root of 5. All right, center HK, but don't forget x and y are in different spots. So the center is going to be negative 3, negative 5. All right, here we go, guys. Everything is a vertical move from the center. So 4 places above negative 5 is going to be -1. 4 places below that -5 is going to take us to -9. And then for our foci, since we do not have a clean, easy whole number for the C value, I'm going to write both foci as one ordered pair. And remember, it's all vertical movement, so the -3 isn't going to move. However, this -5 right here, we're going to go up, so I'm going to draw a positive. We're going to go down, I'm going to draw a negative, and it's that C value of 2 square roots of 5. Okay, let's graph this. Let's go ahead and plot the center. I'm going to go 4 up, 4 down, draw the vertex. 1, 2, 3, 1, 2, 3, 4, 5. All right, both vertices. Don't forget your foci, which are going to be between 4 and 5 places away from the center. Okay. All right, time to draw that invisible box. Remember, the invisible box always goes through the vertices, so I know where the top and the bottom are. Remember to figure out how wide it is. That's finally where the B value comes in. From the center, go 2 places to the right. That's one side. From the center, 2 places to the left. That's the other side. The most important part about these boxes are the corners. That's really the only thing we care about, because that's where the asymptotes are. So once you have your corners, let's go ahead and draw those asymptotes. Don't forget it goes through the center. And guys, we're barely going to fit the branches on this picture, but we'll make it work. We might have to go off the picture just a little bit, but it'll work. So yeah, down here at the bottom, we'll have a little baby branch down there. Okay. Guys, don't forget the only thing the branches touch are the vertices. All right, there you go. Do you guys have any questions on number 1? Okay, let's go ahead and knock out number 2. Here we go, number 2, same process as before. I'll put my x's together and put my y's together. Okay, so 9x squared plus 18x minus 4y squared minus 24y. And that's going to equal a positive 63 because I moved that 63 over. I'm going to factor out a 9 here. It's going to be x squared plus 2x plus a blank. All right, time to factor out that negative, time to change the signs. So take out that -4, y squared is positive. Negative 24 divided by -4 is going to be plus 6y. That's ready for a blank. All right, and again, guys, not too much room for me, so I'll just have that 63 kind of floating at the top right now. All right, time to write them in their factored form. Half of 2 is 1. 1 squared is 1. Bring down that -4. Half of 6 is 3. 3 squared is 9. And again, I'm just going to highlight my values here because I don't want to write the wrong thing on the right side of the equal sign. So 1 times 9 is a 9. And then y'all, 9 times -4 is -36. All right, here we go. So when we add all these, 63 plus 9 is 72. And 72 minus 36 is 36. So this is going to equal 36. But not for long, because remember, they're supposed to equal 1. So we're going to divide all this stuff by positive 36. So the good news is none of the signs are going to change. And we don't even have to rearrange anything because x is positive and it's exactly where it needs to be. 9 over 36, y'all, that's 1/4. 4 over 36 is 1/9. Ooh, look, I forgot my 2 right there. I'm going to put a 2 right there. So this is y plus 3 squared over 9, and it equals 1. Okay, so let's go ahead and write the direction. X came first. It's positive. We know it's going to be horizontal. All right, here we go. A is the square root of the first term. B is the square root of the second term. C is the square root after you add the denominators together. Y'all, there's no perfects in 13, so that's going to stay how it is. Just remember that's between 3 and 4 spaces when we go to graph the foci. My center is at -1, -3. Remember, this is horizontal movement, so here we go. 2 places to the left of -1 is going to be -3. 2 places to the right of -1 is +1. And don't forget your k value remains constant at -3. Foci time. Again, since that's not a clean whole number, I'm going to write both my foci as one ordered pair. That is going to be -1 to the right, to the left, the C amount. And just remember the -3 is not going to change. Time to graph. So when we graph, start with a center at -1, -3. Remember your A value is 2, so go 2 to the right and then 2 to the left. Those are your vertices that we just plotted. Now let's plot the foci. So from the center, we're going to go a little past 3 and draw those foci. Now it's time for the invisible box. I've plotted my vertices, so I know the sides are right here. I just need to find the top and bottom. That's where the B value comes in. From the center, we go 3 up. From the center, we go 3 down. And again, it is all about those corners. So the way this is positioned on the graph, this graph is going to look a lot better than the first one because it's more centered. Okay. Just going to draw my asymptotes, shape my branches, and then that's it. Okay, just one more reminder, y'all. Draw those branches through the vertex. Those other dots are floating around in outer space.